Hi everyone, myself Dr. P. Kannagaraj, Associate Professor, Department of Computer Science and Engineering, Sri Sannuva College of Engineering and Technology. Now we are going to discuss algorithm for asynchronous checkpointing and recovery for that. So we can start with checkpointing. So what is checkpointing? So checkpointing involves creating snapshot or copy of the current state of a system or process at a particular time. So taking snapshot of a process or system at a particular time. So we are called it as an checkpointing. So why we need to take checkpoint? With the help of the checkpoint, so we can perform recovery or we can make a system back to the consistent state in case of any failure occurs. So when the system is checkpointed, the state of the entire system is saved on non-volatile storage. The checkpointing is going to be stored in non-volatile storage. So uncoordinated checkpointing. What is uncoordinated checkpointing? Each process has autonomy in deciding when to take checkpoints. So there is a process. So there are multiple. So generally, in distributed computing, so there are different multiple systems are going to be combinedly going to be solve a problem. All these are going to connected to a network. In a distributed system, multiple computers are so connected through a network so to solve a particular problem here. So in uncoordinated checkpointing algorithm, so each system can take checkpointing so on their own record time. There is no common so time for there is no coordination between these processes to take snapshot. Whenever a process need to take a checkpoint, during the time it can take it. That's why each process has autonomy in deciding when to take checkpoints. It allows each process to select appropriate checkpoint positions. Domino effect may occur during recovery. What is domino effect? For example, system, there is a process XY. So XYZ, assume three processes. So X is doing some operation. For example, so X is taking a checkpoint at particular time. So we can take, this is time 1, X is taking checkpoint. So then next, after taking checkpoint, it also send a message to Y. So Y taking checkpoint at time, so T2 at time, so T2. The next, so Z is taking some checkpoint at time, so assume, so T3. Here what is the problem? Suppose there is a failure occurred for the system, X failure is occurred, then automatically so it will do the recovery process. It will apply the recovery process. The control is back to the checkpoint that this is T1 at time T1 taken checkpoint, the control is transferred. So now, so what about T2? T2 received a message which was sent by X earlier. So after this rollback, so the message is not yet sent by X process X, but it was received by Y. So this call it as an open message. Message is not sent by X now. After recovery, the message is not sent by X, but it was received by T2. So this is called as an open message. So this thing is called as a domino effect. So in uncoordinated checkpointing, domino effect may occur. Since no coordination is taking checkpoints, some process may take useless checkpoints also. In this algorithm, data structures are used. So sent I to J, send count, send message count. So how many messages just are sent from PA to PJ, PA to PJ, how many messages sent? That count is going to be stored so in a data set called send CI. The next, so how many messages sent from PJ to PI? That means PA sent how many messages, PA received how many messages. These two informations are going to be stored. in data structure. Here there are two type of lock storages are used. So one is volatile lock, another one is stable lock. Here in volatile lock, so only which is available for short time access but lost if a process crashed. Stable is a permanent storage, so longer time to access remain, which is in stable storage. Here John Vengadation algorithm, which is followed for asynchronous checkpointing and recovery. Here, so the algorithm is based on asynchronous checkpointing during the recovery. So we need to find the consistent set of checkpoints to which the system can be restored. So in this recovery algorithm, each process keeps track of both number of messages it has sent as well as received from other processes. This algorithm avoids the existence of or sharpened messages. Several iterations of rollback by process are involved in this recovery process. So for example, whenever a process PA rollbacks, if a process PA want to roll to apply rollback, it is necessary for all other processes to find if any message sent by the rollback processes has become an orphanage message. Orphan messages are discovered if the number of messages received by the process PG from process PA so greater than the number of messages sent by the process PA to process PG. So then the process PG must roll back to state where the number of messages received are equal to the number of messages are sent. So for example, process X, so process Y, we can assume, suppose there's a checkpoint 1, so this is a checkpoint is created by process X, then it sent a message. So how many messages sent? One message. For X, send message is 1. For X, send message is going to be 1. So the next, so process Y taking checkpoint here. So for this end is 1, receive is going to be 0. So this process Y send is going to be 0, receive is going to be 1, receive is going to be 1, receive is going to be 1. So due to some failure, so the process X want to apply rollback, so what it will check, so now it will check number of messages send and receive are equal or not. So between these two process, so no, it is not equal, then this may result in an orphanage message, so which is not allowed, this rollback is not allowed. So this is an algorithm for asynchronous checkpointing and recovery. So thank you for watching.